A white world hangs in the darkness. No clouds, no surface oceans, no atmosphere worth mentioning. Just ice, silence, and the faint light of a sun so distant it could pass for a bright star. Then, from its south pole, the ice opens. Long fractures cut across the frozen ground. And from those fractures, water is thrown into space. Not lava, not dust. Water. Liquid water from a hidden ocean erupting through the crust of a moon that every law of physics said should have been frozen solid since the beginning of the solar system. This is Enceladus, and the first thing to understand about it is that it should not exist the way it does. It is only 500 kilometers wide, small enough to fit across the length of Great Britain. At that size, a moon loses its internal heat quickly. Rock cools. Ice locks everything shut. Time turns small worlds into fossils. That is the rule. Enceladus has been breaking it for millions of years. Saturn orbits nearly 10 times farther from the Sun than Earth. At that distance, sunlight delivers roughly 100 times less energy per square meter than it does here. On Earth, that sunlight drives oceans, weather, and life itself. At Saturn, it barely registers as warmth. A small moon out there should be the coldest, deadest kind of object imaginable. Surface temperature on Enceladus averages around -200 degrees Celsius, colder than anywhere ever recorded on Earth, colder than the coldest point on Mars. Before Cassini, that is almost exactly how Enceladus was classified. Interesting, perhaps, because its surface reflects almost all the sunlight that hits it, one of the brightest objects in the solar system. But brightness just meant fresh ice. And fresh ice on a dead frozen moon seemed to require no extraordinary explanation. There was one warning no one was reading correctly. A dead surface accumulates scars. Craters stack up over billions of years like geological receipts. But near the south pole of Enceladus, the terrain looked strangely young. Smooth plains, broken ridges, long fractures, almost no craters. Something had been erasing the evidence of time. Nobody knew what. Cassini arrived at Saturn in 2004, built to study rings, storms, and moons. But Enceladus turned Cassini into something it was never designed to be: a witness. During early flybys, the magnetometer registered an anomaly. Saturn's magnetic field was bending near Enceladus, disturbed and deflected, as though the moon were actively expelling material into space. That was not normal for a small icy body with almost no atmosphere. The imaging team pointed the cameras south. What they saw had no precedent in the exploration of the outer solar system. 4 long fractures at the South Pole, each one roughly 130 kilometers long, spaced with an almost geometric regularity, glowing faintly warmer than everything around them. Scientists called them the tiger stripes. And from those fractures, jets of water vapor and ice particles were erupting continuously into space, moving at nearly 1,400 kilometers per hour, faster than a supersonic jet. But instead of crossing an atmosphere, escaping through vacuum. Some of that material falls back as snow, keeping Enceladus white. Some spreads outward and feeds Saturn's faint E-ring. Part of a planetary ring system was being supplied by a hidden ocean on a moon. That single fact rewrote the Saturn system. But the deeper question was immediate. Where was the heat coming from? The answer is tidal flexing. Enceladus orbits Saturn in a gravitational resonance with a neighboring moon called Dione. Because of this relationship, it cannot settle into a perfectly circular orbit. It is constantly squeezed and stretched by Saturn's immense gravity on every pass. That mechanical flexing generates friction, and friction generates heat. The same principle that warms your hands when you rub them together, applied to the interior of an entire moon. Small by cosmic standards. Enough to keep an ocean liquid beneath the ice, and not just any ocean. an ocean in contact with rock. Cassini flew through the Plumes directly, at its closest pass just 49 kilometers above the surface. For context, that is roughly the altitude where Earth's stratosphere gives way to near space. At that range, Cassini's instruments were effectively sampling the interior of Enceladus from the outside. What they detected changed the nature of the question entirely. Molecular hydrogen. On Earth, molecular hydrogen is produced through a process called serpentinization, hot water reacting with silicate rock at hydrothermal vents on the ocean floor. Those vents exist in permanent darkness, under crushing pressure, with no sunlight and no photosynthesis. And they are filled with life. Life that feeds not on light, but on chemistry alone. Cassini also found complex organic molecules, carbon-based compounds with molecular weights above 200 atomic mass units. Amino acids, the foundational blocks of proteins, typically fall between 75 and 200. What was drifting in the plumes of a moon that should contain nothing but ice and rock dust were large, chemically rich molecules with no obvious inorganic origin. It also found silica nanoparticles of a size range that can only form when liquid water above 90 degrees Celsius reacts with silicate rock. Not cold water, hot water, hot enough to boil at sea level on Earth. Beneath the ice of a moon smaller than Great Britain, warm salt water, chemically active, in contact with a rocky seafloor, producing the same molecular signatures as the most biologically productive environments on our planet. Likely for millions of years, possibly much longer, entirely in the dark. Cassini did not find life. That distinction matters, and it should not be softened. What Cassini found were conditions, but the burden of proof has quietly shifted. If these precise conditions exist on another world, preserved, active, stable, it is no longer obvious why life would not be there. The absence requires its own explanation now. That is a different kind of vertigo than fear. It is the vertigo of a rule you trusted for a century, quietly failing. Then Enceladus wobbled. Cassini's images allowed researchers to track tiny rotational shifts in the moon's orientation, motions subtle enough to be almost invisible, but too large to be explained by a world frozen solid all the way through. If the icy crust were locked to the rocky interior, it would move differently. The wobble made sense only if the shell was floating, separated from the core by a global ocean, not a pocket under the South Pole, not a temporary anomaly. A sea wrapped entirely around the moon, beneath the ice, in permanent darkness, potentially teeming with the chemistry of life. And no one had suspected it was there. The mission that revealed all of this ended on September 15, 2017. Cassini, low on fuel, after 13 years in the Saturnian system, was deliberately steered into Saturn's atmosphere. Not carelessly. If it had been allowed to drift and eventually collide with Enceladus, it risked contaminating a potentially inhabited world with terrestrial microbes that had survived the journey from Earth. So Cassini was destroyed, deliberately, to protect the very discovery it had made. It continued transmitting until the signal was lost in Saturn's upper atmosphere, instruments still active, still measuring, as entry heat overcame the hull. It did not go silent. It was silenced. There are dozens of icy moons in the outer solar system. We have made close passes of very few of them. We do not know how many are doing exactly what Enceladus is doing right now, in the dark beneath ice that makes them look dead. We thought we knew which worlds were worth looking at. A 500-kilometer moon just demonstrated, in the most direct way a moon can, that we had been looking in the wrong direction the entire time. If that changes something for you, subscribe. Void Atlas covers the science that quietly rewrites everything.